Hi. I had hoped to bring handouts because this talk is about taking a program and making it into a better program. And I wanted you to see the program before and the program after. But I didn't bring the handouts. Because of some excuse. So, nevertheless, the handouts are, well, the before and after versions are at these URLs. And I apologize for the lack of handouts, but they should remain at those URLs for a long time. Because when I put something on my website, it stays there forever. Should I begin? Is it time? Is the break over? I don't know how long we told them. How long did we say? It's yes? We're going to start? But I haven't finished my slides yet. All right. Thank you for having me. Konbanwa. Thank you again, Mr. Ishigaki, who has generously put his time to translating the slides. Is this big enough to be read even by the people hiding in the back row? Good. How's that? You have to shout because I can't see your hand if you... Bigger? I'm writing another book now because the first book did not make me suffer enough. The book is... I have trouble explaining what the last book is about. People ask me, what's it about? And I have to go into a 30-minute discussion about Lisp. Then they run away. This book is much easier to explain. Most programs suck. My book, make them suck a little bit less. More specifically, most people, when they come to write code, they write too much. Not just a little bit too much, but like twice as much as they need. Most programs are so overwritten, I can take them and I can remove between 30 and 50% of the code. And when I'm done, it does the same thing, only faster and easier to understand, and with not so many bugs. Sometimes I get a program I can't do that to, but not most of the time. But it turns out it's very easy to do this. You learn to recognize maybe 10, maybe 20 signs in the code that something is drastically wrong, and whenever you see one of these signs, well, it doesn't always mean it's wrong. It just means you should stop and think. If you get in the habit of stopping to think every time you see this, you say, well, I wonder, maybe I have an easy opportunity to make it better here. Then you see, and sometimes it make it better, and sometimes it turns out you don't have such an opportunity. Then you don't make it better. But if you do that for the signs, when you're done, the program is 50% smaller. Why is that? Well, programmers, they like to write the first thing that pops into their heads. And that's all right, because that's a good way to write things. But writers know that it's okay to write the first thing you think of, as long as you go back afterwards and you edit. Programmers don't edit. There's a couple of dozen of these very common mistakes. They're really easy to find, they're easy to recognize, and when you see them, they're easy to fix. And if you see them and you fix them, then your program gets much better. It's really easy. And so the book is a book of case studies. I take a lot of real programs that people have written, things I got from Perl mongers, things that were posted to Perl monks, things I found on CPAN. As Marty said, it's a wonderful website full of really bad code. And then I take these programs and say, well, what could we do about this? And usually you can do something pretty good with it. So the talk is called Program Repair Shop and Red Flags. And a red flag is a visible sign, like a red flag sticking up. It's a visible sign in your code that something might be suboptimal. Very important, might be. Some people will tell you, they'll give you rules. Oh, always do this. Never do that. Those people are lying to you. Sometimes even the worst practice is the best practice. It really depends on context. You've got to try it and see. I didn't know Marty was giving a talk yesterday called Perl Worst Practices, but there's a very good chance when this book is published that will be the title of the book. I want to call it Perl Worst Practices. The publisher seems okay about it. We'll see. Also, I'm trying to get away from right and wrong. This is not about morals. It's engineering. And so, well, things can be suboptimal. Maybe they aren't designed as well as they could be, but they're not wrong, probably. I think programming advice, and style advice in particular, has been too dogmatic over the last few years. Oh, always use strict. Always do this. Never use this construction. Well, you know, there's always an exception. I would much rather see people taking time to think. I should really move on with this. All right, so today's example is not an unusually bad example. I just picked it because it was about the right length for the talk. This talk was going to be in yesterday's hour-long slot, so it's no longer the right length for the talk, but we'll see what we can get through. Probably some of you are expecting me to show horrors. So rather than, I didn't want to start with a program that's incredibly horrible, because then you're going to say, well, sure, he can cut down an incredibly horrible program by 50%. Anyone can do that. I want to show you how to cut down a typical program by 50%. So we're going to take a couple minutes and look at a horror. This was written by somebody I'm not going to name, but it's somebody who should have known better. And it's on his CPAN site, and you could probably find it. Let's see. $P is an array ref, and we're going to join its elements together with exclamation marks. And then we're going to pattern match the result to extract the thing before the exclamation mark and the thing after the exclamation mark. The first one is the sorted key. The second is the unique key. The thing that's so wonderful about this code is if you're the maintenance programmer, you see this. And of course, your first thought is the guy who wrote it is an idiot and an incompetent. But then your second thought is, maybe you're the idiot and the incompetent. Maybe there's something really clever going on here that you're missing. Uh-oh. Because nobody would write it this way unless there was a good reason. Uh-oh. Then you have to figure out why was it written like this? No, it's probably just a mistake. But it's so hard to be sure. This is the kind of thing that makes maintenance programmers pull their hair out. Who here would describe themselves as a maintenance programmer? Wow. Who maintains your code? I'm a maintenance programmer. Well, some people, a programmer I knew long, long ago told me some people are born to be development programmers, some people are born to be maintenance programmers. I was born for maintenance. I love fussing around with other people's code, but stuff like this makes it a little bit less fun. Probably this is the red flag of taking 2 steps forward and 1 step back, where you put some data structure together just so that you can disassemble it again. And then, you know, it's not hard to notice maybe that you've been doing that, and well, why put it together at all if I'm just going to have to take it apart again? Right? Since P probably only has 2 elements, I think we could do this, but who knows? Maybe the goal here is that P has 11 elements, and we're trying to get the first one in here and the rest of them in there. Okay, that's fine. We can do that too. Let's do it this way. We'll copy the elements of P, we'll pop off the last one into the unique key, and then we'll join the rest together into sorted key. I don't know if that's necessary, but maybe it is. All right. So you don't have 2 versions of today's code. Does anybody want to see the URL again? Hands up if you do. Hands up if you don't want to see it. You could just go home now if you want. Don't stay for me. I won't be offended. I speak at conferences all the time. After the talk's over, I'm really happy. I go out in the hall. They say, oh, I left your talk early. Please don't be offended. I say, I wasn't paying attention to you. I don't care if you left my talk early. And if I noticed, I would assume it had nothing to do with me because it was a great talk. Okay, so the before version of this program, about 188 lines, The after version about 126. One problem with writing this book, I tell people I can work over a program, and when I'm done, it has 30% fewer lines. They always say the same thing. Ha! Anybody could do that just by squeezing out all the white space. I'm so tired of that joke. Of course you can do that by squeezing out the white space. That's not the point. No, when I count the lines, I do not count white space. And I don't count lines that have only curly braces or parentheses or other punctuation. I used to have a long section up front of the talk that explained what I count. Now I'm just going to say, I promise I'm not going to deceive you. It's 126 lines of code after, so I've really cut the bulk of the program, the part you have to understand, by 1/3. This is typical. Usually I start looking at these things, let's just skip this, blah, 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 blah. First thing I noticed in my quick pass, but I mean something like this, you don't have to be smart to notice this. You don't even have to be sober. One of the goals of the book is to convince people that you don't have to be smart to write good code. You don't have to write this no matter how badly hungover you are. So who has written something like this in the past? Who's seen one, maybe written by somebody else? Yeah, right. Wow. Maybe quality of code in Japan is better than it is where I come from. Well, this is the world's biggest red flag. It's nice, something like this jumps out, and the biggest red flag is repeated code. When you have the same thing done 2 or 3 or 12 times. Before I even thought of the red flags book, I used to say this to beginning programmers, that this was the cardinal rule of computer programming, is that if you wrote the same thing twice, you have made a mistake. Almost certainly. Not always, only maybe 99% of the time, I think. Why? Let's stop and think about that. Repeated code is a mistake because it's wasteful. Programmers have this problem. They like to think of code as their product. Oh, I am a coder. I write code. That is my job. And the more code I produce, the more productive I am. But that's not really true, because the product is the functionality, right? I work now for some biology project assembling the tree of life, trying to figure out which organisms are related to which other ones. If they could do that without computers, they would do it tomorrow and they would fire me. My job is to produce the tree of life, not the programs. The programs are a means to the end. And if you work for Morgan Stanley, then their job is to make $1 zillion by shaving nickels off of everybody's investments. And if they could do it without computers, they would, and they would fire the programmers. But they can't, so they don't. So the code is a liability. It has a cost, but no direct benefit. It never advances anybody's bottom line, except, of course, the programming shop's bottom line. But it doesn't accomplish anything in the real world outside the computer. If you have twice as much code, the cost is twice as high. It takes twice as long to read, twice as long to understand, twice as many opportunities to get bugs in by mistake. It takes twice as long to test, probably. But if you have 2 pieces of code that do the same thing, if you have repeated code, it can't be delivering twice as much functionality because they're doing the same thing. Probably the cost-to-benefit ratio is almost twice as high. And that's why repeated code is a mistake. Not just because I said so, but for that reason. Repeated code creates maintenance problems. Because if you have the same code in 2 places and someone comes to do a bug fix or make an enhancement, they'll make it in one place and they'll forget to make it in the other place. Has that happened to anybody here? Or does anybody know somebody to whom it has happened? I am shocked at how few hands. I know, it's the end of the second day. Nobody has the energy to. Yesterday's talk is very difficult, so I had Miyagawa put it yesterday instead of now when everybody's falling asleep. Repeated code is boring to write. It's really hard to keep your brain in gear while you're writing it. You drift off. You start thinking about what you did yesterday or what you would like to be doing tomorrow. Then you make a mistake and you have a bug. Repeated code is very hard to read because your visual systems in your brain are optimized for filtering out repeated patterns, even when they're not there. So, for example, we have here a symmetric arrangement of dots. And the symmetry jumps out at you. It's very easy to see that the left side is the same as the right side. And that's almost the first thing you notice about it. Except that that's wrong. Because look at, there's a little cluster up there, but there's no corresponding cluster there. In fact, it's not symmetric at all. Past a certain point here, maybe here, it's completely random. The left side is nothing at all like the right side, except in a very narrow strip down the middle. But that's okay, because your brain is not optimized for accurate direct detection of symmetry. It's very good for your brain to have false positives when detecting symmetry, vertical symmetry especially. Very few objects in nature are vertically symmetric. Faces are vertically symmetric. And if you detect vertical symmetry, it's likely to be because somebody or something is looking at you. Perhaps because they're going to eat you. And it's good to get a false alarm, oh no, it's just a rock, rather than miss a vertical symmetry and be eaten. All the people whose vertical symmetry detectors were not oversensitive have been eaten. And now we have their jobs. But that means it's hard to notice when symmetry is broken, as in this case, or in the code I just showed you. Did anybody notice the bug? Very few people. Let's go back and have a look. January, February, March. It's so hard to see these things. It's not an active bug in this case. It doesn't cause a problem, but honestly, it is a bug, undeniably. Here's a nice example. This is too big. Okay to see that in the back? Yeah. This was posted to comp lang Perl misc Usenet use group a few years ago. Here's the message ID if you'd like to look it up on Google. I should add that every example in this book is a real example written by someone else. I don't make up examples. That's for two reasons. One is that I don't want to tell lies. I don't want to waste people's time and say, oh, and here's a common error that you should avoid, if it's not really a common error. And sometimes I get an idea, ooh, I bet a lot of people do this, and I can help them out by telling them not to do it. And then I go and look for the examples, and I find that no, it's a waste of everybody's time. Nobody really does that. The other reason I have to use real examples is I would never have the nerve to come up in front of you and say that somebody would write this if it weren't true. I would have to tone down the examples out of embarrassment. But no, somebody really did write this. They wrote this. They said, is there a better way to do this? And yes, there is a better way to do this. Well, maybe. Several people on Usenet corrected this to this. They said, look, here is your better way to do it. Well, that's very good, but if you look at the top row, this is 0, 1, 1, 1, 2, 2, 2, 3, 3, but 8, 10, 10. What happened? Now, either the original code was wrong, but nobody who posted a correction pointed out the bug. None of them noticed, which I think proves my point. Or maybe the original code was correct, and none of the people who posted corrections realized that they had broken it, which proves my point even more. So I was very unhappy with our community that day. It's almost always very easy to get rid of repeated code. And that's not for any fundamental reason. It's because repeated code is such a terrible disaster that almost every feature of every programming language ever developed was put in specifically so that you did not have to repeat code. For example, why does Perl have a plus equal operator? Well, because C has a plus equal operator. Okay. Why does C have a plus equal operator? Well, it's so that you don't have to repeat the expression that's on the left on the right, and then the maintenance programmer has to compare them to make sure that they're the same. And if they're not, wonder why they aren't. Why? Well, let's skip that one. Why do we have while and for loops? Well, so that we can repeat code at runtime instead of repeating it in the source code at compile time and having editing problems. Why do we have subroutines? Subroutines were invented in 1952, 49, 1948. Back in the Mesozoic era, subroutines were invented by COBOL programmers, I think, so that they did not have to include the cosine routine in 2 places in the program and then worry about maintaining 2 copies of the cosine routine. They would put it at the end of the program and jump to it when they needed it. So they didn't have to repeat code. Why do object-oriented programming systems have inheritance? So you don't have to put the same method in 2 classes and then maintain it in 2 different places at the same time. So you don't have to repeat code. Why does Perl have modules? So that not everybody in the world has to write their own date calculation functions and maintain them separately and patch updates to them all independently. Why do operating systems have pipes? So not everybody has to write their own sort routine. You can always open a pipe to the sort program. Why do they support shared libraries? So not every compiled program has to carry around the object for printf. And then when you update printf, you have to recompile everything in the world. So all of these features, from the very, very small language features up through very, very large operating system features with support, are there just so that you don't have to repeat code. And with all of these features working for you, there's usually a different way out. In this case, one good approach is to use a table. Instead of this, we'll have a hash that maps the month names to the numbers, and we'll say, month equals the number version of the month name. And we had 13 lines, should have been 12, but it was 13, and they become 4. Questions? Should I go faster? Should I go slower? Should I do a little dance? You have to debug me? What did you say? There's another potential problem here. There's no else clause. A red flag is when you have an if-else series with no else. Again, that's not wrong, and it's often completely and exactly optimally correct to have an if-else series with no else clause. If somebody comes up in front of you and says every if-else, if-else, if-else should have an else at the end, they're stupid. That's not true. But if you see one without an else, you should pause and ask, I wonder if this needs to have an else. And sometimes the answer is no, and then you go on to the next thing, and sometimes the answer is yes. You ask yourself, what happens here if none of those cases is true? And then, well, there are several sorts of answers. Sometimes the answer is, that could never happen. But there's different levels of that could never happen. Sometimes it could never happen because that's not the way the universe works. But sometimes, in this case, for example, couldn't happen, well, the month has to be one of those 12 months because there's only 12 months in the year. Unless the input to the program were malformed or parsed incorrectly. That could never happen. Well, okay, so in this case, maybe it's okay to have an else here. And it's really cheap to put in, so we put it in. In the hash table universe, this becomes that. Assign from the hash or die. Split date looks like this now. Okay. There's the input date string, and it gets parsed into a bunch of components, which gets parsed into a bunch more components, and then we map the month name to a number, and it returns a list of components. Is this talk over at quarter past or half past? Is anybody awake? When's my talk over? Fred. I'm asking that guy with the schedule. Quarter past, 15 minutes. Then I'll start talking very, very fast. Okay, so let's see. Here's a comment. People often use comments as crutches, where they write bad code that they know is hard to understand. Instead of fixing it, they put in a comment. Well, that didn't happen here. I love this comment. I'm not being sarcastic. This comment makes, I can see at a glance, oh, hey, that's what the input is expected to be. It's really concise. It's short. It's informative. And if I don't have that there, it's impossible to know whether the following code is correct, because I don't know what the input was supposed to look like. But this comment clearly says to me, oh, this is what the input is expected to look like. With the comment, the variable names become quite clear. Oh, date, month, day number, date rest, year, hour, minute, second. Without the comment, I really am not sure. So it's great. So some comments, after you clean up the code a little bit, it's clear, and then you don't need the comment anymore. Not this one. I'm happy with this one. See, I'm not just a grouch. So the rest of this function, well, I would not have done the white space the way it was, but it's not important, and people waste a lot of time on stuff like that, I think. I would have formatted the debugging message differently, but it's not important, and people waste a lot of time on stuff like that, I think. Only other change I would really want to make is actually pretty small. Here's line 308. It declares a variable. Why have a separate declaration? Let's just declare it where it's used. If I make that final change, the function has gone from 19 lines of code to 9. There's a lot of white space in this. I'm going to leave it out when I show it on the slides. There's a function here called getDateNow. It's supposed to get the current date in some format. The first thing that's wrong with it is how it does calendar arithmetic. It calls out to the Unix date command, which gets back a string. This is, I think, a diagnostic message. Then it does a split. Then it uses date calc, add delta days to calculate some number of days in the future, or possibly the past, I forget. And it does some formatting here, and then it converts the month to a text, which is, I think, an English name, and then it extracts the, I don't know what the heck it's doing. There's a lot of work, and it's mostly unnecessary. Here's the thing about date calculations. There's three widely used formats for dates inside the program. Format A is completely unreadable. Meet me on this day for lunch. But it's really easy to calculate with. And, okay, format C is easy to read for humans, but it's impossible to calculate with. Format B is partway in between. It would be nice if it were good to calculate with and good to read, but no, actually, it's not very good for either one. It's bad. Oh, well, what can you do? So the secret to date calculations, the way to avoid suffering, going from A to B to C is very easy. I call that downstream. Going from C to B to A is difficult. That's going upstream. Going from C to B is very difficult because you have to parse and understand this is all English. English is difficult. Going upstream, and look what might happen to you. So here's the secret to easy date management. Inside your program, you want to store the dates in format A whenever you can. You keep them in format A as long as you can. You calculate with them in format A because format A is really easy to calculate with. And just at the last moment, right before you produce the output, you convert them to date C, to form C, which is not too hard. You're going downstream all the way. This guy has gone upstream all the way. Format A, let's see. Well, let's skip this stuff. We know how to do it. The slides will be online. So here's getDateNow. He commits his big mistake here on line 98 when he calls the Unix date command. This gives him back a human-readable date, format C. So he started out at the bottom of the waterfall. Now he's doomed to suffer. Recovering from that takes 8 lines of complicated, hairy code. And the date calc module, which is really big. I printed out the source code once, and I dropped it on my foot, and that's why I walk with a limp. If we start in format A, it's all pretty easy. We get the date in format A. We're trying to find out some number of days in the past. Days in the past is you multiply by how many days by this many seconds per day. Then we can hand it to local time to turn it into format B and get the number of the day of the week and the day of the month. There's this wonderful, wonderful function called stirf time. Who knows stirf time? Who does not know stirf time? Okay, those are supposed to cover all possible answers. You either know it or you don't know it. So everybody puts up their hand on one or the other, but not both and not neither. Who knows about stirf time? Who does not know stirf time? Yeah. Who doesn't know about stirf time but is too embarrassed to put up their hand? Yeah, you laugh, but I asked that in Ireland and got a whole bunch of hands. So sometimes it works. All right. Stirf time is in the Posix module, which is standard in Perl since version 5.00000. So don't tell me you don't have it. It takes the output of local time, second, minute, hour, day, month, year, and it takes a format string like sprintf, and it gives you back a string that formats this according to that. So, for example, this formats, it takes the right piece of local time and it gives you back the name of the day, like Wednesday. Or here, it gives you back the name of the month, like February. And it is locale aware, so in France, it gives you back whatever the French people like to call February. Février. So we do this. We extract the month and the day name, and then we concatenate them together into the pattern, and really, I think that's a lot simpler to read. It's probably quicker, and it's less of a terrible mess. We could trim it down some more. Instead of stirf timing twice, we can just use stirf time to generate the pattern in the first place. This says, oh, day name, month name, day of the month. 2 lines. 10 lines of hard code became 2 lines of easy code. Well, let's see. I'm going to go skip out of the date stuff and see what can we do next that's fun. All kinds of stuff. Ooh, refactoring. Let's see. I want to get out of this function and get into a different function. Let's see. Well, this is nice. So here, let's see, we open the input file or die, and then we open the output file or we issue a die, which is fine, but that's the wrong file name. This is advice called say what you mean. That's a little bit fatuous because it's hard to know what you mean. And even if you know what you mean, it can be hard to say it. But here, I don't think it was that hard. So we'll fix this and say what we meant, which is we can't open that file, the one we're actually trying to open, and not some other file. The main logic in this function, this is kind of fun. Because, let's see, here's line, which is recording something, I don't know what. It looks like it's going to contain a line, right? Because it's line. But actually, it turns out that it's Boolean. That's all right, let's see. And then we're going to loop over the input, and if it matches a pattern, we set line to yes. And if line is true and it's equal to yes, then we print it. And then after we exit the loop, we die if line is set but equal to no. Now, here's the quiz for you. How does line get to be set equal to no? Well, never. So the good advice here, I should mention, in this class, on these slides, good advice is in green. And things that I think are probably requiring of additional thought are red. Maybe you picked up on that already, unless you're colorblind. 10% of men are colorblind and cannot distinguish red from green. But really, no 2 colors are quite so attractive. What you going to do? Blue and yellow? Nobody can read yellow. Purple and orange? So the advice here is if you've got a Boolean variable, let it be a Boolean. Perl likes Booleans to be numbers. 1 and 0 work. Set and undef work. Don't go with yes and no, because in Perl, yes and no are both true. I can't think of any language in which no is false. So, okay, if it matches the pattern, we set the flag, which I called seen dpat, because it'll be true if we have seen something that matches dpat. We set it to true if dpat, if a line matches dpat, and then we issue the error message unless we have seen dpat. Did I just spend 3 minutes on this slide? I don't believe it. It must be the end of the second day. Well, here's an alternative, though. Once seen dpat becomes true, it never can possibly become false again, right? Because there's code to set it to 1, but no code to set it back again. So after dpat has been set, this test is superfluous. Whether it's true or false is never going to make a difference. If it's true, we're not going to modify dpat anyway. What this is really accomplishing is we want to scan through the file until we see this, start printing, and print everything up to the end of the file. So, well, we might try something like this, for example. Scan over the file. If you see dpat, print the line and exit the loop, and then print the rest of the lines, which is at least less code, although maybe you don't like it as much, I don't know. The problem with that is without the seen dpat variable, we lose the error message. So we need the flag anyway, something like OK. And then we'll scan the file. If we see the pattern, set the flag, it's OK, print the rest, and then issue the error message if it wasn't OK. I'm really kind of curious. I don't know which one I prefer. Who prefers the top one? Who preferred the bottom one? Who thinks it doesn't make much of a difference? That's fair enough, too. Well, let's see. This test was backwards, and it's not even a red flag, it's just wrong. Because, well, anyway, the precedence is wrong, the test is backwards. bdparse is a good way to check for broken precedence. Who knows about dparse? Who does not know about dparse? Dparse comes standard with, yeah, you guys aren't going to answer that question. I don't know why I bothered asking. Dparse comes standard with Perl since something or other, 5.06 or 8 or something like that. It's a compiler backend. Perl compiles your program, then dparse gets control. It looks at the compiled bytecode and it tries to reconstruct the source code. And so it tells you what Perl thought you meant. So we run this through dparse and it comes back, oh, actually, these parentheses are not necessary because dparse left them out, so they must not be necessary. So what were those for? I don't know. Beginners love to put in extra parentheses. What if we try it this way? Well, then it gives us an alternative that might be easier to read. This means the same as that. That's what dparse thought we meant. And hey, fewer parentheses. Is that easier to read? Perhaps. If you like it, you can use it. If not, ignore it. Dparse with the -p flag means put in all the parentheses possible. That way you can see, gee, did the precedence here go the way I thought it was? Is it taking line, comparing it with no, and negating the result of the test? Oh, no, it is not doing that. It is negating line and comparing the result with no. Oops. So if you don't know what the precedence is, well, you can run it through -p. Let's see, I am now going to, I'm going to do, okay to go 2 minutes over? I'm going to do one more slide, then I'm going to skip to the end. This is just such a fun example. It got cut off here, but that's okay. I looked at it this morning, and there's nothing important after this point. This is a head scratcher. This is another one of those things that makes the maintenance programmers come into your office with an axe. Maybe you don't do that in Japan. You use a big club or something instead. Well, let's see. So this file here, let's see. If it's readable, this is testing to see if the file is readable. If it is readable, we issue an error message. Now, that file was created by this program about 15 lines earlier. So why wouldn't it be readable? Well, maybe the process's UMask is set incorrectly. That's the only, or maybe somebody came along in between and changed the permissions or something. Now, it probably isn't the UMask, because I don't think the guy who wrote this program knows what a UMask is. Maybe it's that he's expecting somebody to come along and change the permissions while he's not looking. I think most likely he just screwed up. I think. And, well, what if the test fails? Well, then it doesn't run the alert error function. It turns out the alert error function is actually the main function in the program. The whole purpose of the program is to issue these alert error messages whenever it's run. And if you don't run this function, there's no point in running the program at all. So the whole program is utterly pointless if this test fails. So the conclusion is it probably should just have been that. What's the test doing there? Well, only 7 of you claim to be maintenance programmers, so maybe I have to mention that this kind of thing shows up in people's code all the time. And since only 7 of you are maintenance programmers, that means the other 143 are development programmers, and you are the ones who write this stuff. Why did you put that test in there? What were you thinking? All right, we're going to go to the end now. I'm sorry, we're here, so if read, do line 438. Otherwise, do some stuff. I don't make this stuff up. I have dozens of examples of this. Who does this? Lots of people. Probably some of them in this room. Okay, so I'm over time now, yes. I did not finish working over the program. I wanted to take several more passes on it. The program itself takes several passes over the same input, once in this function, once in this function, once in this function, if that was enabled by command line. Often, when you have a program that makes several passes, you can simplify the control flow and make it perform better at the same time and reduce the code by having it do one pass instead. There's a function in there I didn't even get to touch, and I thought, wow, that would be cool because it looks from what it does like maybe it would be a good place to use formats. There's something you don't get to say very often. Oh well. But so the important moral here is that even an incomplete pass over the program has a lot of value, and you can get a lot of cleanup done, because most programs are so incredibly terrible that if you just clean up one piece of them, you've made a big improvement. After I was done doing the partial work that I did do, 163 lines of code before, not counting some function I didn't even look at, 101 lines afterwards, so I reduced it by 38%. I think I fixed some bugs, like that thing with the -r test and some other stuff. The performance was improved, I believe, and the code was simpler and smaller. I did it without removing comments and without stripping out white space. This is very typical. So the summary is most programs are too long, not just a little bit, but a lot. Repeated code is very, very wasteful and almost always a mistake. And that you should not be satisfied with the first thing that you write that comes into your head. It's okay to write that, but then go back and say, gee, I wonder if I could do this better. Or write it 3 or 4 ways, and then see which one is best. So I leave you with this thought, that perfection is achieved not when there's nothing more to add, but when there's nothing more to take away. Oh, I'm sorry. This is the wrong slide. Ah. Arigato.
Any questions? Any questions?
Did I what? Yes. Also, I put him on the mailing list so he can get a free copy of the book when it is published. What? Well, that's a good question, isn't it? The question is, when is it? And the answer is, I was supposed to have the final manuscript in last month, but in September, they fired my editor. So I don't have an editor. And I'm waiting for them to give me an editor so I can continue working. So maybe early next year, I hope. And I hope the title will be Perl Worst Practices. But it might be something else. And I have a mailing list, which I forgot to mention, of course. Oh, and I've unplugged the computer. Search for me. You'll find my website. What? Put it on the wiki. That's right. I'll put it all along with the slides. Yes. I have lots of this stuff online also. I have many things to say. Sometimes it's the same thing over and over again. Sometimes it's something new. Almost always 30 to 50% of the code is completely useless and wrong. Any other questions? Comments? Thank you very much for inviting me. I had a wonderful time.